Imagine it's summer last year. In fact, let's imagine that it's August 24th, 2022, around 7 p.m. You're an amateur programmer and a game developer about to begin work on your next game. What is the first thing you do? Well, if you're me, you get an error. Always starts like this. It's tradition at this point. First thing I have to do before I even get into making any game or program much of anything is set up the build environment. Basically, we need to prepare the project as it is, fiddle with the computer so we can make applications with it, since it's not going to let us just do that from the get-go. Some people use IDEs for this purpose, and in fact write their whole programs, apps, games, whatever, using them. IDEs, or Integrated Development Environments, for the uninitiated, are programs that bundle several tools that, in the early days of computing, used to be separate. They bundle them together and just generally try to make the process of setting up the computer for programming, software development, or whatever you want to call it, easier. The key word there is try, because even the best ones require some fiddling. I'd argue some are worse than doing it yourself. But that's both just my opinion and a story for another day, so I digress. What I'm trying to get to is, I don't use an IDE. Every time I start working on a software project like this, I roll out my own solution with a text editor, a couple macros, and a few command line utilities I cobbled together over the years. They all basically aim to give me a lot of the same niceties an IDE would. IDEs can of course do more than my little concoction, but they also generally require more in general. More RAM, more disk space, more resources from the processor. Some are better with this, some are worse. The really good ones sometimes cost money, sometimes they're really bad at what you want them to do, sometimes they are really good. It's just like with everything. You pick your poison and proceed with administering it. This happens to be the venom I prefer, so it's how I chose to do it last year. Oh look, it works now. We can finally start writing some code and have it turn into an application by pressing a shortcut in the text editor. Riveting, I know. Next order of business, we'll give our game a window. Both Windows and Linux usually like it when an app that does something graphical has a window. Since our game will have graphics, we will kind of need that. Lucky for me, someone has already written the code we'll need for window-related stuff. Let's get it. Let's steal some code. From myself. I'm gonna be taking the code from my old arcade game clones and other utilities I've made to help me with game development. It's not always the best idea to use old code in new projects like this, especially in this case, since I took to most of these games and utilities as learning experiences and didn't care to make the apps or the code particularly tidy. What would be the point? They're learning experiences. It usually isn't a smooth fit when I put them in something else. Or a fit at all. That is if they do what they're supposed to, which is also not guaranteed. That bit at the start about being an amateur programmer, yeah, that wasn't an exaggeration. Definitely not when I started writing some of these. Hell, sometimes the old code doesn't work to such a degree I end up rewriting it completely from scratch if I use it in something else. I still find it good to have something that's at least mostly solid to begin with. I can always rip it out later. And hey, if I rummage through old code first, I might get a chance to actually fix it. Perhaps realize that at least I've become a better programmer than the joker who wrote this piece of shit. See? Fixed. And that's the basics. We got ourselves a window and are ready to do something real with it. Oh, you mean like graphics? No. Not yet. It's time for game loop. That is, something gamey that loops. That enough of a description for you? No? Well, the game loop, in the way you can see my past self making it in the background, is a way to get around a basic problem with programming a game. Or in fact, any modern application. The problem is, at some point your game has to end and its window close, and you don't know when. The program will end once a particular function finishes. For C programs that use the C runtime, which, hey, that's what we're doing, that means when the main function reaches its end. Once that one finishes, it's bye-bye application and back to the operating system we go. If we structure our program as a bunch of function calls one after another that just process some data and exit, that's how the program is going to behave. It will launch, do its stuff, and exit. That might be alright for some simple command line utility, but not for a game, or in fact any modern application. You usually expect to keep running for an indeterminate amount of time. You have no idea when it will be closed, so you can't time it, and you might sometimes need it to idle, as in not have it do much of anything, like in a menu or something. How do we do all of that? Simple. An infinite loop. Oh well, not actually infinite, since you can close the game and thus end the loop by doing that, but infinite in the sense that you don't know when it will end. It works like this. At the very beginning of the loop, we do stuff that needs to happen immediately at the start of each frame. Time the start of the frame, reset some variables, the very basic fundamental stuff. Then we start processing input from the keyboard, mouse, gamepad, or other devices we use. If player pressed the enter key, for instance, here's when I hear about it. Then we go and change the state of the game based on that input. You pressed the enter key, and that means, I don't know, I'll start spawning enemies into the level, because I don't like people who press enter. It's against my faith, an insult to my people. After I manage to upset everyone who has ever used the keyboard or in fact a computer in any normal fashion, I go on to throw pixels on screen, loud noises into your speakers, possibly vibrations to your controller. Deal with everything that shows the changes that happened in code up to now, in a way the player can see, hear, or experience. Then we do some bookkeeping to make sure we time the end of the frame right and actually get a reasonable frame rate and not something too fast or too slow. And that's that. We've just composed one full frame of our game. Time to loop all the way back to the beginning and start preparing the next one. We do this, say, 60 times a second, and if we timed it right, set up VSync and managed to get every frame set up in 1/60th of a second or less, we got ourselves 60 FPS gameplay. Pretty good, right? Of course, for now we'll just stick with waiting for 1/60th of a second every time, as opposed to doing anything more involved or in fact smarter. I guess I wasn't feeling that ambitious this early on. I suppose it's better to get the easy stuff working before you plunge yourself into more complicated functionality. We'll see if that bites me in the ass in the future. Time to talk about context switching. Switching between two or more windows on a fly. That's what I mean by it in this case. Alt-tabbing is probably how you know it, but in the programming sphere it's generally called context switching. You're basically switching which window is at the forefront, in focus as it's usually called. When a window is switched to like this, it could be given higher priority when it comes to accessing CPU, memory, and other resources. It will probably also grab the input so that whatever keys you press or mouse movements you make will be registered in that window and not somewhere else. My past games didn't usually do that so well. My Space Invaders clone does that so badly, most of its versions I can't even launch on Windows without some serious patchwork. Although to be fair, that might also be because of the way I chose to implement timing in that game, but that's a story for another time. The Pong clone is even worse. If we are in the game portion, I think we might be okay, even if we alt-tab and leave it running in the background. However, if you go to a menu, alt-tab, and leave it running, then the game will crash after about 40 seconds. In fact, it does that even if you just leave it when it's focused. They just don't do well with idling, my games. The Pac-Man clone does a little better. Alt-tabbing doesn't spook it. It just keeps running no matter what, even if it doesn't have focus. That's a good idea, right? I'm sure my operating system is loving the fact I'm using the CPU cycles even when the window is inactive. I think with this game, I finally managed to figure out how to get this working well enough. Here you can see me set up a system where I keep track of when I have focus and when I don't. If I don't do anything. That seems to be just fine as far as the operating system is concerned. Here's to actually using the functionality SDL2 had for this, even back when I started working on my first game. I could have used it back then, but, well, I guess you learn eventually. If I say texture, you probably imagine something that wraps itself over a 3D model of some kind, right? You've seen my game, you know that's not what I'm using my GPU for. But I'm still using textures, because as it turns out, you don't need to have them bound to 3D models to use them. You can just set them flat inside your window, draw pixels to them, and have your GPU actually accelerate the whole process. That's what I did here. Every texture is basically like a sprite layer, a canvas on which I'll draw the different sprites, hence the name. Since these textures tend to be more resource intensive in SDL, at least compared to what the rest of my code is usually doing, I always try to start with just one or two, or in this case 3 I guess. The ones I use here are main, overlay, and off-screen. It's what it says on the tin with each one. The main one is the main one, where most of everything will be drawn. The overlay is there for future lives counter and UI stuff like score and whatever I need to put in text. And off-screen is off-screen, hidden from the player since it's where we do various hacky shenanigans or optimizations when I need to draw something, but fiddle with it before I show it to the player. Thinking back now, I ended up using a lot more textures than this in the end, a lot more than I probably needed. Maybe I could have done with just these 3, possibly one more. Maybe that's something to consider for my next game. In my experiences so far, having a lot of textures usually means the game will use more memory, even though up to now it usually didn't matter that much. Sure, using say 700 megabytes of RAM might not sound like a lot, but if the game looks and sounds like this, it feels ridiculous. Using less of them might be something to consider for my games in the future. Oh boy, I'm really not proud of this one. If you recall back to the last episode, I mentioned an example of using SDL2 to get window resizing on screen. Well, as it turns out, back in August last year, I was obsessed with resizing in one specific way. Let me show you a problem I was trying to solve by doing that. What if, when resizing the window as you would, it would always snap to not leave any blank space in the window? Sure, you could have the window contents resize themselves to match the window size every time the window gets resized. This, I would argue, doesn't work that well in our situation. It works well for 3D games, possibly high-res 2D ones if you pick the right kind of interpolation, but it doesn't really work for pixel art. It destroys it. I mean, just look at it. It's disgusting. I get that a lot of people might not care about this, and you might get used to this. Hell, I did back in the day. I used to play a lot of games stretched like this. But nowadays, it infuriates me when I see a game do this. So we're not gonna do that in this game. And since we're not gonna do that, we need to somehow solve a problem. We need the image in the window to be big enough for the window, but small enough that nothing gets cut off around borders. Nothing strange about that, even my Pac-Man clone does this. See? This bit isn't difficult at all. The resizing to fit the window, not that difficult either. Or at least I don't think it's difficult now. Back when I made this, it was a different situation. I poured a lot of hours into making it work in some particular way that I thought was good, only to find out it didn't actually make sense. Questioning if people wouldn't just get confused by this, because sometimes I would get confused by how it worked. I rewrote it again and again and again, trying to get it slightly better each time, becoming more and more deranged with each iteration, until eventually it kind of clicked. When I was first preparing this, drawing to textures was also not working, so I had to fix that, Since you kind of need something to be drawn in the window to see how it resizes, and I wasn't getting anything drawing in the window, that meant I had to fix that first, just to see if my smart window resizing was actually doing what it was supposed to. Which it most likely wasn't, but we'll get to that later. For now, I got better sights to show you. Look! I get a black color filling my window. What more could a growing boy need? Well, how about some actual sprite? Some image. Something to show that the drawing functions are actually drawing pixels as opposed to vomiting jumbled mess on screen, which is, at this point, still a possibility. I don't remember what exactly possessed me to make the game's logo as the first image to test if the graphics worked, but nevertheless that's what I chose to do first. It must have just been easier. I don't think I knew how the main character was going to look this early on. I might have still had images of the white jumpsuit guy from Dig Dug on my mind, and since I wasn't about to make the game look like a Dig Dug clone, I knew I couldn't make the player avatar look like that. You might have noticed me naming the games folder Drill in the background. Originally, that's how I wanted to name this game. Later on, I came to my senses and realized that giving your game a one-word name is a quick way to ensure it will get confused with something else, especially if it's a common word like, you know, drill, but that's skipping several months of development and multiple different realizations. At this point in August, I was still hell-bent on naming it Drill, so there had to be a drill somewhere in the logo. Oh, there it is. Wow, that looks bad. And it doesn't draw in the window. Great. You see, if I didn't try to be smart with my faux sprite layer textures, I might have had something drawing here. That's premature optimization for you, I guess. You try and make it better from the get-go, and then it takes longer to get it going, and you might later find out it needs to be completely scrapped anyway. Yay! It's drawing it! But not how it's supposed to. It was supposed to scale it up to fill the screen. That's the point of this whole exercise. Get it drawing and scaling to show if my smart window resizing works. Well, it's centered at least, but it's still not scaling. Even worse, it's refusing to draw it at a lower or higher pixel size if the window gets resized. You know, I'm getting tired of looking at this logo anyway. Let's make it better. At least make something that doesn't blend into the background so well. Alright, that's something. It stands out, I'll give you that much. Still a little derpy looking. Come on, we can do better. Turns out we could. I mean, doesn't that look like something? I still don't think it's gonna win any awards, but I wasn't overwhelmed with feelings of disgust when looking at it, so it was good enough. Oh, forgot a pixel there. That'll teach me to use dark brown for outlines. Alright, will it finally fix the sprite scaling? It does? No, not really. Still a little small in the window. Finally! It's working as it's supposed to. Still a little jumpy, but I'm calling it a win for now. Let's see if I can get the input handling working. Computers have keyboards, right? They had them pretty much from the beginning. High time we actually use a keyboard in the game. Some input handling. I mean, we have been using input already, but only for stuff related to the window the game is running in. Closing it, resizing it, alt-tabbing in and out, stuff like that. Fetching input from the keyboard is a little different. Actually, a lot easier, I think. You see, keyboards are in some ways pretty dumb devices. Underneath that RGB lighting and fancy switches, it's really just a bunch of inputs that can be turned on or off. A bunch of buttons. Each of those buttons can be pressed, not pressed, or released, as in someone stopped pressing it recently. If you're using SDL2's input handling in the way I'm doing here, that's literally how it works. The keyboard is just a bunch of buttons. It's possible it works differently under different libraries, and it's definitely different if you're writing, for example, a keyboard handler from scratch, but since I'm not doing that here, I'm gonna talk about the keyboard just as a set of buttons. Pressed, released, and not pressed. Here you can see me trying to set up some basic actions. I probably wanted to map arrow keys to movement here, until I got stuck. How do I get at this thing again? Time to look at the documentation. And some more documentation. Oh, wait, I remember now. Never mind, back to the manual again. Ah, so that's how it calls the arrow keys. Man, if I just mapped it to WASD, I could have done this already. Let's see what I did next. Oh, wait, I forgot about this. Oh, I was so stupid. I tried making moving up, down, left, or right each a separate virtual button. Oh man, was I silly. Each of these buttons would be in a list that I update when a key was pressed or released, and use that list elsewhere in the code to figure out if a player should move and how. As if it made sense to check for movement in all 4 directions every single frame. I mean, in a Mario game, you can move up and down at the same time, right? That's possible and makes sense? Yeah, this is just silly. There are other buttons that make sense in this setup, so that idea wasn't completely ridiculous, but come on, me. Why would I want to even make it possible for a player to go up and down at the same time? Just think of the many wonderful bugs that could bring! Like handling both events one after another, likely in random order since sometimes user would press up first, sometimes down first. If reacting to both, that means I have more possible bugs to watch out for, since there's more possibility and more opportunity for me to screw up initializing, setting up, or clearing the various bits of data that tell what's supposed to happen when user pressed up or down. Just another wonderful idea. Luckily this time it will be a short-lived one, as I saw the light relatively quickly and reverted back to a more sensible way of doing things. Okay, back to window resizing hell. A nightmare of my own making, by the way. At any point, I could have just decided not to mess with any of this. Do what most games do and just let you pick one of fixed resolution options in a menu and have the window resize precisely to that size when selected. I would only give you resolutions that scale well with the game's internal resolution, that way I'd get around the possibility of awful non-integer scaling and stretching. But I didn't choose this path back then. I chose the path of pain instead. Since it was so early on, I didn't even care enough to write anything about why I chose to do this in my notes. So, since it's been over a year now, I don't remember what possessed me to even try something like this. My bet isn't just throwing shit at the wall and seeing what sticks, but honestly, who knows at this point. Anyway, back to your regularly scheduled programming. The smart window resizing seems to be working fine. It's still very janky though. Do I really need to redraw the entire window every time? Yeah, I do actually need to. Wow, that wasn't supposed to happen. The logo isn't drawing at all. Okay, works again, for whatever that's worth. Let's get back to something sensible again. When you play a game, you expect to be able to do certain things, right? You can expect to be able to go to a menu, you can expect to win the game, lose the game, perhaps go to different levels or areas, maybe even trigger scripted sequences. But when we want to do that in our game, how do we turn all of that into code? Stands to reason if we go from playing the main part of the game and we want to even bring up a menu or inventory or something of that sort, we will most likely need to change what, say, moving a mouse does. When you open an inventory in a modern 3D game, for instance, You probably expect the mouse to no longer turn the camera. If it just kept turning as you mouse over different options in the inventory, it might be disorienting, possibly even induce motion sickness. You want a lot of controls, graphics, the state of the game in general, to behave completely differently than when you're not browsing your fat stacks of loot. Not to mention, you might even want to pause the entire world when you're browsing your inventory. If we want to make that happen, we need to know when we want the game to behave like the main game part, when like the inventory, when like the pause menu, and when like a scripted cutscene. All those changes need to be conceptualized somehow so we can turn it into code. How did I go about doing that? Easy! State machines. If this isn't your first devlog, you probably heard of them. They are a computing concept that is used to break down logic of how a piece of software or hardware is supposed to work. For example, let's take a door. A door can be opened or closed. To get it open, something must open it. To get it closed, something must close it. That kind of stuff. If you use them for figuring out different game states of your game, like I did, it might end up looking like this. You have the main game state, gameplay, then the game state of when the game is started, game start, when the game is being closed, game close, game menu, when a menu is being drawn on screen, and possibly many others. Ideally, if you're a good little developer, you draw them all out, or at least most of them, write all the relationships between them, from which state you can get to where. From gameplay you can go to game close and maybe game menu, but probably don't want to go to game start, since that one is assuming the game is being started from scratch with no prior state, and is initializing things for gameplay. Then you test them, either by using the old school way of testing them by converting them to truth tables and then checking those, or try using some more software related solution where you draw all of your state machines in an app, and that same app then checks your state machine scribbles to make sure that it's all okay and proper. If you've been watching so far, however, you might have guessed that I wasn't a good little developer here, but unlike a lot of other times when that bit me in the ass, here it mostly worked out. The setup in my game is basically the same as I described in the state machine example. The game has several states it can be in. What state it's in dictates what will be drawn on screen, how the controls are interpreted, and what happens in the game in general. Here you can see me setting it up so that when we are in the main state, gameplay, the game's window is filled with red color. You can also see it doesn't work. Not because of a bug in the code switching between different game states though. That bit of code is so simple at this point, I would have to have been really stupid to make a mistake there. No. It turns out the mistake was instead related to drawing to textures. Remember that from earlier? Well, it's back to punish me for trying to be clever again. I didn't properly set up how the textures are drawn on top of each other, and also forgot to set the metadata I keep about them, their width, height, and position. This could have ended up being useful later in development when I wanted to move entire layers. But I think once it came to that point, I ended up hacking together something completely different, because by that point, the codebase was structured in such a way that just using this metadata would get so clumsy it would not have been worth it. So I guess I actually ended up not using these for much of anything. More features that didn't need to be there, I guess. Anyway, the window fills with red and green when switching between different game states. That means it works so far. Time to add more states we'll deal with at a later date, and move on to something else yet again. Aha! Data structures where dimensions and position will actually be used more. Sprites! Oh, don't get too excited. There's not going to be any sprite drawing for now. We're not there yet. Before we get to that point, we need to make sure we don't completely lose control of the code once we introduce more than just a couple sprites. You can set up a small tent without too much preparations or forethought, but building even a small house without at least foundations is just asking for trouble. Turns out game development? Not that much different in that regard. It's time to more properly organize how we handle graphics. A lot of ways to go about organizing graphical assets in a game. The way I chose is indexed arrays. You have a bunch of sprites, you stuff them in a list one after another, and give each one of them an index which is the same as their order in that list. If I want to pick a sprite related to the player, I pick that one by just slurping it off the sprite list, which I literally called sprite list. I left the imagination for other parts of game development, I guess. Each sprite has a bunch of data associated with it, like dimensions, position, and obviously the image data itself. That brings us to another interesting point to what I did here though. In a previous video, in my quick explanation, I mentioned using my own BMP-like format with a minimal header for graphics. What was that about? Back in early 2021, I started working on my own image editor that would be geared up specifically for creating pixel art. I mainly worked on it to improve my programming skills and come up with something simple I could use to create graphical assets for my games. I also wanted to be able to create animated sprites and see the animations actually play out in the editor. I called this app Spread, as in Sprite Editor, as it was primarily meant for sprites, both static and animated ones. Since I was making something simple to give me simple ways of creating pixel art sprites, it stands to reason that I wasn't going to use something like JPEG or PNG for a format, since they're not really meant for pixel art, or sprites, or anything like what I'm doing. There are probably some formats out there I could have used for sprites. Had I done that, you would actually be able to open what I would make in Spread in a regular app. You would just get a regular image viewer and just be able to open it right then and there. But I didn't do that. In the quest for more learning, I created my own image format. It's simplicity itself. Just raw, uncompressed pixels stuffed into a file with only a little bit of info to tell you how to treat them. There are two extensions in the format that dictate if the file is a static sprite or an animated one. Well, dictate is maybe a strong word, suggest is more like it. Those are SPR and SPRA, standing for sprite and sprite animation. The static sprites just have info about width and height. Sprite animations have width, height, and frame count, which tells us how many frames there are in this animation. That way we can tell not only where one frame begins and ends, but also when we should reach the end of the file, which is handy for preventing errors when reading this data from files. Depending on if it's a sprite or animation, we either read these 2 or 3 pieces of information, and the rest of the file is just raw data. No compression at all. This is good because it means we don't have to decompress it when we use it. Less code, less instructions for the processor to churn through, less time wasted loading graphical assets and trying to decompress them. It's also bad because uncompressed graphics, understandably, take up a lot more space. So far, I still haven't reached the point where this would become a problem. Hell, in the last build of Drill Dave, all its graphics, including level data, still take up less than 400 kilobytes. So it was still very much workable even for this game. That's how my image format works, how I made and stored the graphics for Drill Dave. I'd make them in Spread, then use the same routines I use in Spread to load and draw them on screen, to load and draw them in the game. If you were wondering what I was using when you saw me make the logo there, that's what that was. It isn't going to impress anyone with its UI design. In fact, it's not going to impress anyone with its ease of use or most things in general. It's at times still really tedious to use, but since I made it, I can also fix it and make it less aggravating should I want to. That's in fact something I did after finishing each game I made. The Spread as you see it here was a lot more stupid and a lot more simple back in 2021, but it did a little more after I finished my Space Invaders clone, and a bit more yet after I finished the Pac-Man clone, growing more useful with each game. Also harder to fix as it becomes bigger and clumsier beast with each new functionality added, but that's a story for another day. We take the keystrokes, we know when the player pressed the key, but we don't do anything with it. That is about to change right now. I considered fetching the keystrokes and doing something with them in the same place. That is how I did it in the Pong clone I made. However, in that one I was also working with very limited controls and also just very limited game in general. All that was needed there was just keys for moving up, down, and starting the game. Even back when I recorded the footage we're watching here, I knew I was going to do a bit more than just up, down, and start. Different game states are also going to require me to change what, for instance, the attack button does in different situations. Better to abstract it away so we don't make a big mess in one file and make it easy to create more bugs that are harder to find. Better to make bugs that are easier to find. Like this one. The player, here shown as a gray square, is responding to me pressing keys, but doesn't want to stop responding. It doesn't matter if I stop pressing right or down, he just keeps going in that direction no matter what. Silly me. I didn't respond to when player releases a key, just when he presses it. There we go. Starts moving, moves, and stops moving. Great. Wait, what are you doing? No, I said we don't want to get input and act on the same place. That's going to turn into a mess when we handle what happens during different game states. Don't do that. I don't even know what's happening here. It might make sense initially to directly update the rectangle that tells us where the player is, but it's not a good idea to update it right away for a ton of reasons. It's definitely not a good idea for the way I usually handle collisions, for instance. And now I'm all surprised it's sluggish as hell. I wonder why. Thankfully, I came to my senses. Eventually. Back to working order. Time to deal with diagonal movement. Normally, when you can press buttons to move up, down, left, or right, you might allow the user to also move diagonally, in 45-degree angles from up, down, left, or right. But since the game we're making is inspired by a game that very much doesn't let you move like that, and for a good reason, we need to prevent the player from being able to move in such a way. Moving diagonally could be done here, to be fair. You could dig diagonally, maybe that could be cool. But considering how I set up the level layout later, I'm thankful I didn't get the idea like that back then, because it would have taken quite some time to get it right and possibly not have been a good idea. So no moving up and down at the same time. You can only do one. We also probably should figure out how to deal with the user pressing them at the same time, but apparently this early on I just made it impossible to move any other way than straight up, down, left, or right. We'll come up with some smarter solution for this at a later date. Now watch closely. I'm about to attack. Very exciting, right? This is just about pressing a single key, since there's no reason to have more than one input for this, but that one button does a little more than just a simple one and done attack. Again, we're making a Dig Dug inspired game here, so we know what this needs to eventually turn into, right? When the button is pressed at first, player is supposed to shoot something at the enemy, and when that something catches the enemy, then what the attack button does changes. From that point on, it doesn't shoot anything anymore, it does some other activity, like pumping for instance. One press equals one pump equals one change in the state of the enemy as they get more blown up with each press of the attack button until they eventually pop and die. So we don't really have a simple attack per se. We still have a relatively simple attack, as opposed to what you might find in, say, a fighting game with complicated grabbing mechanics, but it needs more info than just, are we attacking or not? We need a bit more logic there. And since we need a bit more, let's get that more in our game. Here, I'll introduce attack state and timers related to that to make sure attacking isn't quite so easy, and set up stuff we'll need later for getting it working. Wait! Stop! What do I see here? A static variable. That's a wonderful idea. I'm sure that's not going to bite me in the ass in the future. Well, moving along. A game like this has levels, right? Closed off chunks of scenery, enemies, scripted events, and other interactable doodads meant to be entered, played, and hopefully won. You win one level, you go into the next one, and the next, and the next, and the next, and the next, until eventually reaching the end of the game. That's how these kinds of games go, and mine isn't going to break any new ground in this area. Just like with everything we've done thus far, we need to take what's in a level and turn it into something we can store as data. Preferably ones and zeros, since computers seem to like those. That's what you see me setting up here. But only the really basic stuff, the foundations, the bedrock. I'm not actually gonna use it for anything yet, so I'll wait with a full explanation of how this all actually works. I'll wait until I actually use it for something. For now, looking at it just makes me laugh, because as you can see in the background from me changing all the structures and their names, I made some decisions that were so stupid I tried to fix them almost as soon as I made them. Like the name of the main structure for loading the levels. Not much else to see here, just some old, boring game development bookkeeping. Okay, why am I going back to smart resizing? That temperamental BS worked already, why mess with it? Oh, I wanted to make the screen go blue in resizing. Granted, it looks a little janky when the window contents are jumping between lower and higher pixel size when you drag the window borders. Making it go blue at that point makes it look at least slightly more professional. I wouldn't even go that far though. Bearable? There we go. Still, I spent almost an hour on this and it's not that great. Oh, it goes blue when you move the windows as well. Never mind then, it's actually shit. And I shouldn't have bothered because in the end this functionality ended up not being that important or used in any meaningful way. We went through a lot in this one. Maybe too much. I'll see how much I end up cutting out, and I will have to cut some of it out because, my god, the script itself is already at over 45 minutes worth, and that's not even counting for pauses, delivery, and various other bits I'll need to keep quiet. Basically, I'm not surprised if most of you have passed out already. I suppose it's time to try and wake you up. Hey there, buddy! Your cat is on fire and your bathtub is overflowing! Sorry, I just had to go for it. What do we find in this video? That creating bugs is my passion, and this doing-it-yourself exercise is only proving to be more frustrating with each day I work on the game? You could take that from this video. I can't stop you. These rough beginnings are to be expected, though. I can tell you with reasonable confidence that even for how rough this was, it definitely went better than my first couple days making the Pong or Space Invaders clones. What I've shown you is what I managed to do in about 10 hours worth of work. With the clones, I was lucky if anything was drawing on screen at all after the first 10 hours. Nobody said this was going to be smooth sailing. Also, nobody said this was going to be time-effective sailing. I could have done more in those 10 hours, which brings me to some takeaways I'll try to take from this one. So, what have I learned? I probably should have ignored the whole window resizing BS, set the game's window to a fixed resolution and deal with it later. That's what I did with every other feature in these first 10 hours. Had I done that, I could have already improved the input handling or sprite drawing or something else that needed my attention. Have I learned something else? I suppose to not overthink the input handling or graphics drawing. That one gets a little more complicated though. The solutions I'm trying to create here, the complicated ones, as you will, are still ultimately pretty simple, so dealing with them isn't that much of an imposition. Also, if I get them set up right away, I don't have to worry about them later. Maybe I could have not done the logo at this time, or spend less time on it at least. Lucky enough for me, I did end up being mostly okay with the final version of it, even in the future, so I didn't have to redesign it later. But it still probably wasn't a good idea to design a logo this early. I'm lucky I knew the game was going to have a fairly obvious inspiration and stuck with it. Had it been a more original idea, or I changed my mind at a later date, I might have had to scrap it completely when I later realized it didn't fit the game anymore, thereby wasting all the time I spent working on the thing. By the way, I took almost 2 hours to design all the different variations of the logo. Likely that could be attributed to me not having drawn anything for a long time at that point, and coming up with it right then and there. But still, that's a lot of time to spend on something that could be scrapped in the future. Glad I got lucky enough it didn't have to go there, I guess. Taking old code was both good and a bad idea here. I could have been more selective, but then again, how can you be sure it doesn't fit until you try and put it in? I don't have much to say about other stuff I did here. You just don't know some things at the start. Some initial stupid ideas are probably inevitable. Maybe having a plan would have been a good idea? I didn't have one here, but from what I remember that's going to really become a problem later. Here it's not really showing its ugly side yet. And I think that's it. That's all the advice I had for me from a year ago. Strange little creature, that guy. Always making decisions I don't remember making. Speaking of memories, at the time of writing this, I still haven't looked at the footage for the next one yet, so I have no idea what the next one is going to be about. I'm sure it will be exciting, because if it won't, I'll just skip it and show you the next bit of footage. Ah, the magic of editing. Hope you had a fun time. I'll see you in the next one.